Hi, today's topic will be dealing with solving systems by substitution. The objective is, how do we solve system of equations using substitution? So we need to know what the substitution method is. Basically, it's exact solution of a system of equations can be found algebraically by substituting one variable in for another. And the steps to finding the solution using substitution are, the first is choose one of the equations and solve for one of the variables. And 2, substitute the solution of the variable into the second equation. 3, solve for the variable. And 4, substitute the solution in one of the equations and solve for the other variable. So right now you may look at this and think, oh, these are words and steps, I don't get it. We're going to do examples showing how we use these steps in order to use substitution method to solve systems of equations. And just as a reminder, we did substitution, not substitution, we solved for systems by graphing in the last lesson. So now we're doing it algebraically by using the substitution method. So for the first one, we have two equations. So imagine if these two equations were on the graph, and where they meet is the point of intersection, and that's the solution for both of these equations. But we don't have a graph, so now we have to do it algebraically. All right, so for this one, the first one says y equals 3x. The other one says x plus 2y equals negative 21. All right, so in order to solve this, we're going to do by substitution. So basically, let's look at the first one. This one says y equals 3x. I'm going to circle the 3x. So that means in the other equation, wherever there's a y, we're going to plug it into, we're going to substitute it with 3x. So I'm going to rewrite this equation. I'm going to use the x plus 2y, and I'm going to have y in green, because that way you'll know that this is what we need to substitute the 3x for, and equals negative 21. And then I'm going to have x plus 2, and up here this is y equals 3x, so I'm going to put 3x in for y, and I'm going to use green. And so we are consistent, and you can understand where it's coming from. And it's equal to 21. All right. So notice how this has x and this has x. Now I'm able to actually solve for x. Because whereas this one, there was two variables, you can't solve an equation if there's two variables. Unless you have one of them that is substituted with a value, but in this case, we have to actually find both. But in order to do that, we're doing substitution, because we need to find the point of intersection for both of these equations. So we continue, we simplify. This will be 6x equals 21, and then you can combine these two. It will be 7x equals 21. Divide 7 on both sides, and then we're going to get x equals negative 3. So we solved for 1. We're not done, because I know this is new, and I know some of you are going to just end up solving for one of the variables and totally ignoring the other one. There's two that we need to solve. All right, so since x is equal to negative 3, we're going to choose either the first or the second equation. Whichever you want to choose is fine. If you want to choose this one and plug in x, that's okay. But I'm going to go with the easy one, y equals 3x, and I'm going to put that in blue because that was what I solved x in. And then I'm going to replace or substitute the x with negative 3. And I'm going to put that in blue. Now I can simplify and find my value for y. And 3 times negative 3 gives me negative 9. And I got negative 9 for y. and I'm going to put, this was the first thing that I did, and in the second I solved for x, and the second I solved for y by substituting what I found for x into one of the equations. So now my final answer will be in this form. It will be xy, so I'm going to put xy, and it's going to be -3, -9. So that means this is the point of intersection. So if you were to graph this, you would see that this is the point of intersection for these two lines. And in order to check yourself, you can take this point and you could plug it back into this equation and see if it works out. And you know what? I will do that to show that I got the right answer. So I got x plus 2y equals -21. I'm going to plug in my numbers, and I'll use the colors that I chose for them. So this is -3, and then I'll just put this -9, and I'll put the other numbers and symbols. So plus 2 times -y equals -21. -3, this will give you -18. And then -18 plus -3, or -3 minus 18 is -21 equals -21. So it checks out. So this is the correct answer. So that's how you solve systems by using the method of substitution. Let's do another one. All right, for this one, let me look at it. I noticed that this is written in a standard form, but I need to take one of them and turn it into either y equals whatever or x equals whatever. So I'm going to take this one, the first one, and I'm going to solve for x. So I'm going to put solve for x. You could solve for y if you wanted to, but this one I'm going to solve for x. So I got x, so that means I'll have -5y on both sides. Cancel out. Then I have x, and this will be, I can't combine these because they're not the same like terms. So then this will be -5y minus 3. So now I have x equals this. So now wherever there's an x, I'm going to use the second one, or wherever there's an x, I'm going to plug in this expression. And I'm going to circle this, and then circle the x. So that way you know that I'm doing this by substitution. So I'm going to take the second equation. I'm going to change that to purple. Yeah, purple. So that way there's some consistency. And then I'm going to -2y equals 8. And then wherever there's an x, that's what I'm going to replace it with. It's going to be, get back to that, so -5y minus 3. And then I'm going to put -2y equals 8. And like again, notice that there's this the same variable, so that way we can solve for y and then go on to find x. So this one we have to distribute. So this would become -15y. This would be -9 minus 2y equals 8. Combine like terms. So this one's by itself. The -2 and the -15 give me -17y minus 9. Add 9 on both sides. -17y. And then this will give me 17. You divide -17 on both sides. And then cancel this out. And this will give you -1. So I found y. Now I need to find x. We're not done. I'm going to choose another color for this one. So I'm going to choose the set of the first equation. You don't have to go back to this one. If you're going to use one of the equations to substitute and solve for the other variable, go with the original. Don't go to the one that you've changed it to. Go to the one that you started off with. So this one will be x plus 5y equals -3. The y, let me change that to, oops, trying to choose eraser. I'm going to put that in blue, so that way you know that's what I'm substituting to try to find y. And I'm going to put that in underneath, and then the rest I'll bring down. So x plus 5 times -1 equals -3. And then I'm going to solve for x. This gives me -5, -3, positive 5 on both sides. Add 5 on both sides. Cancel. And you get 2. And I found x. So now my final answer will be in the coordinate form of x, y. So that's 2, -1. Make sure that you put it in order. So it's x, y. X goes first, your y value goes second. And that's your answer. And like I said, if you're not sure, take those points, plug it into one of the equations, and see if it comes out to be a true statement. And if it does, then you did the right thing. All right, let's do another one. Okay, so this one has y equals 3x plus 2. So that means wherever there's a y, I'm going to substitute that in there. So let's go with the first step. I'm taking 6x minus 2y equals -4. And then I'm going to plug in, oops, that was a weird x. I'm going to plug in whatever y is, and that is going to be equal to 3x plus 2 equals -4. And then I'm going to do distribution. So this would be -6x. And then this -2 times +2, -4. And then I'm going to combine like terms. This gives me 0. This is -4. And then this is -4. Net minus 0 minus -4 is just -4. Okay, so yeah, -4 equals -4. But what does it tell me about this 2 system? It tells me that the answer for this, which I'll put in red, the answer means when you have a number equal another number on the other side of the equation, that means your solution is all real numbers. So all real numbers. So that means I could choose any value for x for both of them and get the same y. And there's not a specific point. And the reason why this is all real numbers, let's change. I'm going to take another color for this one. I'm going to take this one. This one is y equals 3x plus 2. I'm going to change this to the slope-intercept form. So I'm going to do 6x minus 2y equals -4. I'm going to be solving for y. So that way it's y equals whatever the expression is. This would be -6x minus 4. I have to divide -2. And then this will give me, when I simplify, it'll give me 3x, and then this will give me +2. Look what's happening here. We had the y equals 3x plus 2 for this one, and then when we changed this from standard form to slope-intercept form, we got the same equation as the second one. So when you look at this, that means this is the same line. And what we remembered from graphing systems, if we have the line, the same line on top of each other, that means there's infinitely many solutions. So that means it's going to be all real numbers that you can choose. So I can also put infinitely many solutions. So again, when you see that, when you try to solve for one of the variables and you end up with this situation, it could be 5 equals 5, -3 and equals -3. then you know it's going to be infinitely many solutions. Because this is the same line, it's on top of each other, and they're sharing all those points between the two because it's the same line. All right, let's go on to the next one. We have x equals 2y, and we have 4x plus 2y equals 15. So this 2y, wherever there's an x, I'm going to substitute it in there. All right, so I'm going to take 4x plus 2y equals 15, and then I'm going to substitute the x with 2y. So that way I can solve for y. That's going to give me 8y. This is going to be plus 2y equals 15. And then I'm going to have 10y equals 15. Divide 10 on both sides. And then y is going to equal, if I get my calculator, I can reduce it, but I want to get numbers, so it'll be 1.5. So use that as a decimal. So my y is 1.5. Now I need to find x. I'm going to use another color for that. So I'm going to use the first one, x equals 2y, and I'm going to substitute y, 1.5 for y. So then x equals 2 times 1.5, and then I'm going to get 3 as an answer for x. And then my final answer will be in coordinate form, xy, that'd be 3, 1.5. And I'll just put that to remind you that x comes first and then the y. And there we go. Okay, one more. All right, so now we have to change one of them to be either y equals whatever or x equals whatever. And I'm going to change, which one will I take? I'll take this one and I'll change it to y equals. So that's my first step. So I'm going to subtract 4x on both sides. Cancels out, be y equals negative 4x plus 11. All right, so that means wherever there's a y, I'm going to replace it in here. Replace negative 4x plus 11 in there. So I'm going to take the next equation, and then I'm going to substitute y with negative 4x plus 11. And then I'm going to distribute. And I'm going to put that in another color to show you that, don't forget that you need to distribute. So that will be, oops, why do I do that? Undo. So that would be negative 8x, and this would be positive 22. So then when you combine this one, this will give you 0 plus 22 equals 13. And then 0 plus 22 is 22, and then you got 13. So you know that 22 does not equal 13. So then what does that say about these two lines? The answer is that there's no solution. So answer, and with that symbol, with the 0 and the slash in it, no solution. That means doesn't matter if whatever x I choose and whatever and then the y I get from it, it's not going to match. It will not work out for the other equation, and vice versa. So that means there's no solution. And that can happen. That can happen. And again, to show you where this is no solution, if you think back to when we were graphing our systems, which type of system tells you that there's no solution? If you answer that it was parallel, you are correct. And I'm going to prove that. I use black now for this one. I'm going to change, well, since I changed the other one, so that was 4x plus y equals 11, I change it into the slope-intercept form of negative 4x plus 11. I'm going to do the same thing with the first one and change it into the slope-intercept form. So I'm going to subtract that 8x on both sides. Then I get 2y equals, oops, we got 2y, make sure I got everything. Yeah, 2y equals negative 8 plus 13. And then subtract 2 on both sides. Y equals negative 4x plus 13 over 2. All right, remember what I said about no solution, it's parallel? Look at the slopes. This one says negative 4, this is negative 4. When you have two lines have the same slope, that means they're parallel. And when you have parallel lines, they'll never meet, they'll never have a solution, so therefore, no solution. So there you go. Everything is all connected. Everything that you learned before, it's being applied here, but differently. But again, it all ties up. All right, so I think that was the last one. So we're just going to recap what we just learned. We learned about dealing with systems, solving systems algebraically. One of the methods that we've learned was substitution method. Basically is taking one of the equations and substitute it into the other one to solve for one of the variables. Once you find that variable, then you find the next variable and you get your point of intersection for those two lines. There's different types where you'll have a solution, one solution. There's going to be others where you have infinitely many solutions. Basically, it's the same line. And then you're going to have another one where there's no solution because the lines are parallel. Right, so if there are any questions about substituting method, again, you know you can email me or ask during class, and I can provide you with information and steps for you to understand. Right, so this concludes our lesson, and have a good day.